If you want to classify mechanical engineering, there are several classifications. This is a broad classification which is kind of universally accepted. Mechanical engineering can be broadly classified into 3 streams. One is the design stream, one is the manufacturing stream, and one is the thermal engineering stream. In the thermal engineering stream, we look at energy conversion, how to convert heat to work. When you have a heat engine, what are the various processes, what are the various kinds of equipment you have to design and build in order to accomplish this conversion of heat to work and so on. And then how do you build your refrigerators, air conditioners, power plants, automobiles and automobile engines and so on. That is thermal engineering. Design, again. No, you're going. Design. So you want to design first, before you make the car, you have to design it and do analysis and find out whether there are stresses. What is the kind of stress distribution on the car and whether it can survive a crash test and all that, and what are the materials which have to be used and so on. Then manufacturing, how do you come out with tools and machines which will eventually make this. So design, manufacturing and thermal engineering are the 3 broad sub-disciplines of mechanical engineering. So I can take, so there are various ways in which I can proceed from now. I deemed it fit to take 2 examples. First is the automobile and then the satellite launch vehicle. And then we'll see how mechanical engineering comes into play through these 2 examples. So the original car was developed by Benz, so it is from, the automobile came from Germany. So if you look at the original car, it looks like what? It looks like our cycle, the familiar cycle rickshaw, right? And then the automobile of the 20s, then the automobile of the 50s, and the last one is the Ford Fusion hybrid. Okay, the last one, the black car, is the Ford Fusion hybrid, which I've put there. So if you can see, what are the improvements you can see? Very good, tires. Now we have got tires with tubes. And then what else can you see in the wheels? Okay, first point is tire. No. Hang on to tires. Spokes went off. Then you've got tubes. Alloy wheels. Then the size of the tire. No. Stick to the tire now. Tubeless tires. No, why are you jumping? Wait. So tires, there's so much. Then look at the body. The original 1886, the body was mainly made of wood. Now it is lot of aluminium. Even the engine is aluminium. Okay. Now look at the size of the engine for the 1886 car and the modern car. Even this 1950 also, the front part is mostly the engine. So the engine has become critical because people want more speed, more control, everything. Then there were no mirrors. Now you got mirrors, right? Side view mirrors. Then what else? Headlights, parking lights, central locking system, DVD player. Okay, ABS. What is ABS? Okay. So what does it do? It helps you to prevent skidding, right? When you're taking a sharp turn, when you're overspeeding. Is that enough? Shall we proceed to the next slide, or you want to? You want more? Okay, you keep telling. GPS. Then. More accidents. If you look at more accidents, but if you look at the number of vehicles, the number of accidents, number of vehicles, I don't know whether the ratio has gone up or not. Okay. So do you believe that mechanical engineering is growing at such a fantastic pace? Yes. Legs are the brake. See, he is asking, oh, you're all laughing. He is asking, sir, whether the original one had brakes. Okay? I said probably the legs could have had brakes. Nowadays, see, when you're driving, somebody will cross the road, you do like this. So he tells me that your brake is in my hands. He will simply shh. Then I have to do this. Okay. Now you have to clap. Tata Nano, come on. Okay. So, if you go to Google, Wikipedia and look at the automobile, so the Tata Nano's picture is there, just as you had the Benz original 1886 car. So the Tata Nano is a major innovation, is one of the major things which has happened to cars, because the Tata Nano is probably 1.25 lakhs or whatever base version. Don't worry about stories of Tata Nano going up in flames and all that. That is only a few cars. But it meets all the European emission norms, all the Indian emission norms. It meets all the crash tests. It costs less than 1.25 lakh. Now look at the other one. That's a sports car. Okay, one of the world's most expensive cars. Power is about 700 to 800 horsepower. But what is the ultimate car? Bugatti Veyron. You want to see that? Next slide. No. Go further. Go further. Further.
Cost 1 million.
Okay, so the Bugatti Veyron. The Bugatti Veyron is the world's ultimate car. So Bugatti Veyron is the Italian sports car, but top speed is 400 kilometers per hour. The power is 1000 horsepower. So it is a power of 1000 horses. For some reason, the original FPS, the British system of power was used in multiplication of number of horses, right? But which horse? There is a problem, right? And so 98.6 degrees Fahrenheit should be the normal body temperature of who? No, of a horse. No, don't connect all these stories. So that is one more example. Okay, so these standards are all arbitrary. So even if you put a thermometer now, there will be a variation. Maybe the average may be 98.4. So 98.6 degrees Fahrenheit is the average body temperature of a British male who doesn't have fever. That is the original definition. Why only British male? Why not an African female or African male? So now also these are so you're all laughing and all that, but it leads us to a very important concept called we need to have standards. We need to have standards in the measurements of various quantities, standards in terms of mass, length, time. And then the International Conference on Weights and Measures, they met and decided that something will be kept somewhere and everybody has to follow that. From that, national standards will evolve. From national standards, regional standards will evolve and so on. Okay? Now, let's go back. Now, what's new in cars? This is the Toyota Prius. It's a hybrid car. Toyota Prius is available for sale even in India. It's very expensive, but so hybrid car is one that can be powered by electric power and petrol or diesel. So it is one of the world's most successful cars. It is also one of the cleanest cars in the world. At the same time, one of the most fuel efficient. It can give you an incredible fuel efficiency of 30 kilometers per liter. Yeah, I think if it gives that, we should be happy. But that is only for crazy people, right? Okay, now. What is this hybrid car principle? When you are frequently starting and stopping in city traffic, the electric power takes over. The regenerative braking, when you are braking, the excess power can be used for charging the batteries. At cruise, excess power produced by the petrol engine charges the batteries. On the highway, only the petrol engine works. So incredible fuel efficiencies and low carbon emissions. Of course, the internal combustion engines IC engine people are also catching up. They are saying that we can try to do all this by using the petrol engine itself. There is no need for the hybrid because the hybrid is additional investment and extra weight and all that. But the Toyota Prius in US now I think has a waiting time between 3 months to 6 months. It costs about $25,000 to $28,000. Okay. We have already seen the ultimate car. So second example. Let us look at a second example where we are looking at an interdisciplinary science, namely the interface of mechanical and aerospace engineering. So satellite launch. So you know that if you want to put a satellite in orbit, you need a launch vehicle. Okay, the launch vehicle is usually a rocket. A rocket is required that can give high velocities. What is this rocket principle? A rocket pushes itself forward by continuously ejecting out material. Rocket is quite different from a cannonball from a cannonball in the barrel of a gun, or a bullet which leaves the pistol, because it constantly ejects mass, its mass keeps reducing and it accelerates further and further. Because if you want something to escape out of the Earth's gravitational field, you have to give an escape velocity which is equal to 0.2 meters per second? Wow, 1.2 kilometers per second, but that varies at various heights, right?